The next concept is fibers. So in that we are going to study nylon 66. Okay, nylon 66 fiber. Okay, before going to understand this nylon 66, first let us know what do you mean by fiber, right? Already we have explained. So what is this fiber? So just let us recall that definition, right? So fibers, if a polymers are drawn into a long filament type like materials whose length is at least 100 times than its diameter, then the polymer is said to become fibers, right? So these fibers are thin, right, and long and thread like polymeric chains which do not undergo any deformation or stretching, right? They will not undergo deformation or stretching, right? So these long chain polymeric molecules, the long chain polymeric molecules are held together by hydrogen bonding in case of fibers, right? So if you can see the examples for these fibers, so silk and wool are the natural fibers, and nylon 66, Kevlar fiber, carbon fiber, glass fiber, all other things are the synthetic fibers, right? So with this, now we can go to nylon 66. Those are fibers. So nylon 66 is an aliphatic polyamide polymer, right? It is an aliphatic polyamide polymer. It is prepared by the condensation polymerization of adipic acid and hexamethylene diamine, right? So with the elimination of simple low molecular compounds such as water, we are going to get a product, and that is called as nylon 66, right? So if you can take adipic acid and hexamethylene diamine, so it will be CH2 4 times COOH and COOH. If you write this is called as adipic acid. So adipic acid and hexamethylene diamine are the monomers for the synthesis of nylon 66, right? And hexamethylene diamine will be CH2 6 times NH2, right? Hexamethylene diamine, and this is adipic acid, right? It is 4 times. So if you are taking n moles of hexamethylene diamine, and if you are taking adipic acid, and if you are taking n moles of hexamethylene diamine, let me write the name, right? Hexamethylene diamine, then these two undergo condensation polymerization, right? These two undergo condensation polymerization with the elimination of simple low molecular weight compounds such as water. We are going to get a product, right? And that can be written, so that can be written here like C double bond O, right? C double bond O, okay? So these two should undergo condensation polymerization, right? So we need to get the polymer. Actually we should have to write this to this side. Okay, we can write the structure. Let's start from this, right? So NH CH2 6 times NH, and then C double bond O, right? CH2 4 times and C double bond O like this, right? N times, right? N times. So in this way the structure is going to form, okay? This way the polymeric structure is going to form. So I will write this. So these two undergo condensation. Once again I will write this. So NHOH and 1H will go, and what is remaining is NH and CH2, right? 6 times, then NH, and then C double bond O here, and CH2, okay, 4 times, and C double bond O will be remaining, right? So this NHCO group is called as amide group, right? As it is consisting of a linear aliphatic chains, this is a aliphatic polyamide, right? So this itself is called as nylon 66. This product itself is called as nylon 66. It is prepared by the condensation polymerization of one is adipic acid, the other one is hexamethylene diamine. Okay, remember. So coming to the properties, so if you come to the properties of this nylon 66, right, so it is a dense molecule, right, it is having highly dense molecular structure and very high melting point, right, high dense molecular structure and very high molecular weight, right, high dense molecular structure and high molecular weight, high melting point, right, very high melting point. Coming to the second point, so it is having high tensile strength, right, and it is extremely elastic in nature, right, it is having high tensile strength, right, it exhibits strength, so it is stiffness, very strong stiffness, it exhibits very high stiffness, and it is extremely elastic. And if you come to see the third property, these nylon 66, as they are fibers, they are resistant to wear, tear, chemicals, acids, alkalis, inorganic salts, UV rays, heat, etc. Right? They are corrosion resistant also. Right? So these are all the properties of nylon 66. Okay. Coming to see the applications. So if you see the applications, these nylon 66 found application in majority of the fields, right, they are used in the manufacturing of tires and conveyor belts, right, they are used in the manufacture of tires and conveyor belts, right, they are used for floor coverings, and they are used as a floor coverings and furniture coverings. They can be used in the manufacturing of drive gears and bearings here. So they can be used in the manufacturing of sliding doors, airbags, window stoppers, and they can be used in the field of textiles, apparels, and tire cords, right, in the manufacturing of tire cords. So overall, so they found application in so many fields, and this is the properties and applications, right. So if this is the formed by the two monomers, one is adipic acid, the other one is hexamethylene diamine. Okay, so remember. So if I repeat the application, it can be used in the manufacturing of tires and conveyor belts, and then floor coverings and furniture coverings, and in the manufacturing of drive gears and bearings, and in the sliding doors, airbags, and window stoppers, and last is textiles in the manufacturing of apparels and tire cords they are going to use, right. So this is all about our nylon 66. Next concept is adhesives. Okay, adhesives. So what are these adhesives? We have heard this word, isn't it, right? So these adhesives are the polymeric non-metallic compounds, right, which can hold firmly two materials together by surface attachment, right. So these are the polymeric non-metallic materials which can hold firmly together two materials by surface attachment, right. A very best example for adhesive is epoxy resin, right. So these adhesives are thermosetting polymers. Capable of holding or binding two surfaces together, right. So they are thermosetting polymers, right. So these are the epoxy resins, right. Once again I will repeat the definition. So these are the polymeric non-metallic compounds which can hold firmly two materials. These are the polymeric non-metallic compound which can hold firmly two materials together by surface attachment. The best example is epoxy resin. So now we can see the synthesis, right? Synthesis, properties and industrial application of this epoxy resin. See, the trade name for this epoxy resin, right, or araldite or epon. Araldite or epon are the trade names for the epoxy resin, right? So this epoxy resin is prepared by the condensation polymerization of bisphenol A and epichlorohydrin, right? This is prepared by the condensation polymerization of bisphenol A and epichlorohydrin. So as a result of which we are going to get epoxy resin. So if we write the structure, so the bisphenol A, CCH3, the structure of bisphenol A will be like this, right? The structure will be like this. You can write OH and okay, and if you can write another benzene ring, right, like this. This is a bisphenol. This is bisphenol A, right? This is a bisphenol A. This undergo condensation polymerization with epichlorohydrin, ClCH2 CHCH2. O will be attached like this. So n molecules of this, n moles of this, if you take it and if it undergoes condensation polymerization, then we are going to get a product, and that is called as epoxy resin, or the trade name is araldite or epon. So the reaction will be, or else here only I will write this synthesis. So NHCl will be eliminated, right, and it undergoes condensation polymerization, right? So what we are going to get is O minus O, and then, right, so like this, and this will remain as it is, CH3, and then this, and this OH will go, O will be there, and it is going to form CH2 and CH, and now CH2 will become CH and O will be there, okay, and N times. If you can write N times, then it is called as epoxy resin polymer, right? Epoxy resin, it is a thermosetting polymer, right? Epoxy resin, right? So it is a thermosetting polymer. So this is all about the synthesis. The monomers are bisphenol A, structure is CCH3CH3, this benzene ring, and this is epichlorohydrin, right? Here I have not written the name. This is epichlorohydrin. Okay, so epichlorohydrin. So that is the name of this monomer. If you come to the properties, of this epoxy resin, right? It is a polymeric non-metallic compound which can hold firmly the two materials together through a surface attachment. So the properties are, this is resistant to water, acids, alkali and various solvents, right? Just like all other polymers, it is resistant to water, acids, alkali and other various solvents. And if you look at the second property, it is a very good skid, wear or abrasion resistance or tear resistance. Abrasion resistance it is going to exhibit. And the third property of this epoxy resin is this cured epoxy resin shows more toughness, right? Cured epoxy resin shows more toughness, more adhesion, and this heat resistance property, right? More toughness, more adhesion, heat resistance property. And at last, these epoxy resins possesses good insulation property, good insulating property, right? They possesses a very good insulating property, right? So one is they are resistant to water, acids, alkalis, various solvents, etc. And this is they are skid resistant, wear resistant, or abrasion resistant. And here, so this will, the cured resins are exhibiting more toughness, more strength, and adhesion and heat resistance. So these are the properties. So coming to the applications of adhesives or epoxy resins, the main application is it is used as an adhesive for many surfaces such as glass, metals, and another surface coatings, right? So these epoxy resins are mainly used as an adhesives for holding the two surfaces together by surface attachment. And second one is they are used in industrial flooring as an adhesive, right? And in the commercial name or trade name araldite or EPON. And the third one is, so they can be used as a laminator or laminating material or impregnation material on the surfaces, right? And the fourth one is they can be used as anti-corrosive and anti-fouling coatings, right? They can be used in anti-corrosive and anti-fouling coatings. So these are all the applications of epoxy resins, right? So one is used as an adhesives for surfaces, so many surfaces such as metals, glass, and other surface coatings, and then in industrial flooring, and then it is used as a laminator for laminating material and impregnation material. And one more important use or application of this epoxy resin is it is used in the manufacturing of fiber reinforced polymer composites, right? Fiber reinforced polymer composites, because it is a resin, right? So two components will be there, one is matrix, the other one is resin. So here they can be used as a resin, so they will be they will be reinforced, right? Or they will be adhered into the matrix, so that in order to make the fiber or composite more stronger. So that is another important application of epoxy resins, right? Now let us see about the composites, right? So here we can understand the introduction to these composite materials, right? The properties and application of these composite materials, and then after understanding all those things now, and then we can go and understand about carbon fiber reinforced polymer composites as well as metal matrix polymer composites, right? Metal matrix composites, right? So coming to this word composites, how one can define this? So what do you mean by composite, right? So usually the composite materials are first developed for military and aerospace application in the year 1940s, right? In the year 1940s, especially the polymer composites, right? So especially the polymer composites, okay? See, the composites, right? It is a combination, as the name implies, it is a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications. They are called as composite materials, right? So composites is a combination of two or more new materials in order to generate, right, a new class of materials which are which are suitable for structural applications, right? So if one of the component is a polymer, then it is called as a polymer composite, right? So then one can call it as a polymer composite. Like that, if one of the component is I will tell about classification later. So coming to the composition of these composites, right? So usually composites consisting of two components. The one is a matrix, the other one is a matrix, the other one is a fiber, right? So matrix is usually a thermoset polymer material, right? So which is capable of embedding, encapsulating, reinforcing, or adhering, right? So it gives stability and strength to the composite materials, right? And it will define the salient chemical, mechanical, electrical and physical properties of that composites. This only will decide, right? And if you can look at the examples, so you can take an example of epoxy resin, right? Epoxy resin, polyester, phenolic resins, bakelite, so etc. can be used as a matrix in the synthesis of a composite, right? So it is a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications. So coming to this fiber, the second component in this composite, fiber is any fibrous materials which give network structure to this matrix, right? Which will give network structure to this matrix, right? So if you see the examples for these fibers, usually the most commonly used fiber will be glass, and sometimes people are using Kevlar fiber and carbon fiber, right? Kevlar fiber and carbon fiber, right? So this is the thing, usually these fibers will be embedded or reinforced into the matrix, thereby in order to make matrix stronger, right? This will make matrix very stronger. These are the examples, right? So if you look at these composite materials, the main feature of this composite material lies in the fact that they are lightweight, right? They are lightweight and they are very strong, right? See, they are strong, they are often stronger than steel, but weight is very much less, right? So this is the reason why people are going to use these composite materials in the manufacturing of so many aerospace applications and in automobile applications, in order to make automobiles lighter, thus thereby achieving higher fuel efficiency, right? So this is some introduction about these composite concepts, right? Composite materials, right? So if you come and see the classification or types of these composite materials, we can classify these composites into three important types based on the matrix used. Based on the matrix used, we can classify composites into three major types of composites, right? So the first type is, here I will write, the first type is ceramic. First type is ceramic matrix composites. This is one of the type. The second one is polymer matrix composites. Polymer matrix composites. Right, and the third type is metal matrix composites. Metal matrix composites. Remember, right? Polymer composites, polymer metal matrix composites, ceramic matrix composites, and metal matrix composites. Right. So these ceramic matrix composites can be further classified into two types. One is short fiber composites, right? Short fiber composites, and this is long fiber composites or continuous fiber composites. Right. These polymer matrix composites can be classified into thermosets. See, this is important, thermosets and thermoplastics. Right, thermosets and thermoplastics, right? So they are further classified into into three types. One is glass fiber composites, right? Glass fiber composites. Here it is organic fiber composites, organic fiber composites, and third one is carbon fiber composites, right? We can write this carbon fiber to this side. So carbon fiber, right? Carbon fiber composites. This is glass fiber composites. Remember, glass fiber composites, right? So this metal matrix composites can be further classified into three types. So one is particles reinforced, short fibers reinforced, and the plates reinforced, right? Particles reinforced, right? Particles reinforced, and then plates reinforced, so reinforced, and then whiskers reinforced, whiskers reinforced. Remember, so like this one can classify the composites, right? Composites are a combination of two or more distinct components in order to form a new class of materials which are suitable for structural applications, right? So once a composite is formed, it is going to exhibit excellent properties compared to this matrix alone as well as fiber alone. So this is the beauty of these composite materials. Coming to this, so if you can see the fibers, here I have given the example for polymer composites. The fibers are used glass, Kevlar and carbon fiber. If you can see for ceramic matrix composites and polymer matrix metal matrix composites, see the different types of reinforcements they are used, right? And they are called as, right, different types of reinforcements that is used in place of fibers, and they can be classified reinforcements that are used in the manufacturing of composites are, so there are four major types of reinforcements are there. First one is particles, right? Second one is short fibers, and the third one is continuous fibers or fabric materials, and fourth one is plates or sheets. Okay, plates or sheets. So like particles means they will be looking like this. Okay, if we can just, I will give a picture representation like this. These particles will be looking like this. Okay, short fibers means you need to take a short fibers of this size and shape. Okay, so like this it will be there. Okay, and continuous fibers means we can write like this. It will be like continuous from the other side also, opposite side, continuous to the opposite side also, right? So like this. So coming to plates and sheets, so that if you can write like this, they will be arranged in the form of sheets or plates like this. Okay, so these are all called as various reinforcements that are used in composites, right? So remember, so if you can see the properties, general properties, I am not restricting this to only polymer matrix composites or ceramic matrix composites or metal matrix composites. In general, if you can see, they are very, very strong, but weight is very much less, right? They exhibit high stiffness, very strong, very high impact strength, tensile strength, everything will be there. The one of the very, very important feature of these composite materials is their high strength to weight ratio. This is important. High strength to weight ratio, right? So that's why I told that they are often stronger than steel, but weight is much less than that, right? So that is a thing. So just like that, any other polymers, these composite materials are resistant to chemicals, resistance to corrosion, wear, tear, impact resistance, and then resistance to heat, fires, etc. So they exhibit low distortion properties, high excellent creep resistance, right? So like that, low density, that is light in weight, right? So these are all the different properties of these composite materials in general if you want to list. So coming to the general applications, right? If you can list out the applications of these composite materials in general, right? So you can list out so that they can be used, right? Here I will write, right? They can be used in so many advanced fields, right? In so many advanced fields, such as like they can be used in infrastructure applications, right? For the construction of buildings, bridges, right? Roads construction, right? Highway construction, flyover construction, there also they can be used. That is one thing. They can be used in thermal engine and blades. They can be used in automobiles, aerospace industries. They can be used in the manufacture of rockets, missiles, satellites, right? And they are also used in electronics, right? And in the packaging of things, right? And then in biomedical applications, right? In missiles, military applications, there and all, these polymer composites or composite materials can be used, right? So this is all about the general introduction about the composites and the components of this composite. That is, one is matrix, the other one is fiber. These are the different types of reinforcement, because usually these fibers only reinforced into the matrix in order to make matrix stronger, right? But its chemical, physical, mechanical and thermal characteristics will be decided by this matrix, right? Based on the matrix, we can classify these composites into three types: ceramic matrix composites, polymer matrix composites and metal matrix composites. So based on the reinforcement used, they can be further classified into sharp fiber composites, long fiber composites, thermosets and thermoplastics, right? Carbon fiber composites, this is carbon fiber composites, right? Organic fiber composites and glass fiber composites. See, under polymer matrix composites, we have already discussed about Kevlar fiber composites. So now in this session, let us, after completing this concept, let us take a carbon fiber reinforced polymer composites and then discuss. Coming to, and then metal matrix composites. In metal matrix composites, based on this reinforcement, they can be classified into particles reinforced, plates reinforced and viscous reinforced, right? So based on the knowledge of composites, now let us understand these carbon fiber reinforced polymer composites or carbon based composites, reinforced composites, right? So carbon fiber reinforced composites, right? Polymer composites. In short, they are called as carbon based composites, right? That you can call it as carbon based or CF or P, carbon fiber reinforced polymer composites, right? See, they are advanced polymer composites, or they are advanced composites. So, and they are of very much use. So why? Because they show great versatility. This carbon fiber based polymer composites shows great versatility. So why? Because versatility. Why? Because the presence of carbon atoms, right? So they enable them to chemically bonded with any of the other carbon based materials and with a wide variety of different elements in order to form very strong covalent bonds, right? Based on the presence of carbon atoms, right? So that's why it makes carbon based fibers more versatile than any other fibers, right? So as a result of which, so these carbon based materials start to exhibit excellent properties, like they exhibit high strength, high flexibility, right, high density and then high hardness, right? So if you can look at the carbon based fibers, they weighs around of about 25%. They weighs about 25% less compared to steel, and they weigh 70% less compared to aluminum. Just imagine, right? This carbon based fiber reinforced material weighs 25% less than steel and 70% less than aluminum, but they are equally stronger than these two metals by weight, right? So that's why their high strength to weight ratio is a very important aspect of any of the composite materials, right? So this is the thing. So if you look at the properties with this introduction, if you look at the properties of carbon based fiber composites, carbon based composites in general, I can call like this. So you can list out so many properties like this, right? So they are going to exhibit high strength, high stiffness, hardness, toughness, right? And they they can exhibit high load bearing capacity, right? See all these things, etc. And then lightness, right? And high damage tolerance, low damage tolerance, so low friction coefficient, and then good wear tear, chemical, corrosion resistance, heat resistance, fire resistance, right? Excellent creep resistance, right? Creep resistance. All these things are the very important properties of these carbon fiber reinforced polymer composites, right? So you can list out like this. So high load bearing capacity, low density, they are very stronger, but weight is much lesser than that of these metals, as I said, right? And then high toughness, right? High strength. So in this series you can give high toughness, right? Highly rigid, high hardness, it is very light, that is lightness. Low density it is called as, right? So coming to the next point, it has a low damage tolerance, right? Low damage tolerance, and then it exhibit excellent wear resistance, wear, tear, chemical, right? Corrosion, fire, heat, and resistance, right? And it exhibits excellent creep resistance also, right? Creep resistance also. So the low friction coefficient, that also you can list out. Low friction coefficient, right? So etc. makes these carbon based composites are more versatile, right? And coming to the applications, so general applications, I already told, these composite materials found applications in the advanced fields such as in the construction areas, in the thermal engine and blade, in automobiles, in aeroscraft, in military, rockets, missiles, satellites, in electronic fields, and in biomedical fields, and in packaging fields, etc. So if you go more specifically with respect to this carbon fiber reinforced polymers, right? So you can list some of the applications. They can be used in aerospace applications, right? In aerospace applications, in order to make helicopter wings, right? So helicopter wings, and then landing gears, right? And other wings or seats, etc. can be manufactured. Coming to the automobile industry, these two are the most important fields of application. These composite materials find application in these two fields, very important, right? In automobiles, they are used in the manufacturing of body panels, they are used in the manufacturing of shaft, bumpers, gears, right? Engine parts, etc. It will be used. So in the field of sailboats, right, they are used in the manufacturing of hulls, and then deck, etc. So in recent days, they are used in the manufacturing of bicycles, advanced bicycles or modern bicycles and motorcycles, and at last you can call it as modern cycles, and motorcycles. So they are bicycles, right? And at last they are used in consumer goods, in the manufacturing of variety of consumer goods such as laptops, tripods, right, hockey sticks, archery, right, tennis rackets, right. I will write only consumer goods, tennis rackets, right, and then fishing rods, and then golf clubs, in surfboards, in billiards, and in making of helmets and shoes in case of racing sports. So in all those fields, these carbon fiber reinforced polymer composites, carbon based composite materials are used.